Guys, as you can tell by the thumbnail, we're going to talk about Q-Day, and it's not the older Q that we heard about and was so famous a few years back. But this Q-Day is the hypothetical day when a quantum computer becomes powerful enough to crack the public key encryption. Again, that's RSA and ECC, and they currently secure the global financial system, military communications, and the internet. For years, experts thought Q-Day was decades away. But what they've done now with what's called Google's Willow quantum chip, Willow just like the tree, has sped up the calculation time by 13,000, or sped up 13,000 times, guys, over the very fast speed of all the legacy supercomputers. Now, the Willow chip came out a couple of years ago, but Google instantly put it in a black box. In other words, not tied to the main internet, so they could play with it, experiment it, test on it, see if they could improve it for over a year. Now, they've kept it in the news occasionally by mentioning improvements and all. Kind of that may be also a financial way to keep investors interested. But anyway, they are now 13,000 times normal speed. The timeline for this hypothetical Q-Day is coming about much faster. Again, global financial systems, military communications, and the internet. Now, why is this moving the clock forward? The threat of Q-Day relies on a math formula called Shor's algorithm, which proves that quantum computing or computers can easily factor large numbers to break modern encryption. Historically, doing this required tens of millions of unstable physical qubits, something decades out, and that's what they thought. But Google has completely changed this math in two ways. Again, when it came out first in 2024, they black boxed it, kept it off the internet, and keep it private so they can do all the testing, all of that, and releasing small bits of information. But because they need fewer qubits, guys, it's going to affect things like a much lower power consumption. That's a good thing. But they have published, and this is from the Google Quantum AI researchers, a bombshell white paper revealing that optimized quantum algorithms could crack standard encryption using under 500,000 qubits. This is a massive 20-fold reduction from previous resource estimates. That's one of the reasons that the timeline has jumped forward, and they're starting to, again, see the breakout, different groups of AI agents. And one of the things that really caught people's attention, and I think the reason it was black box for so long, is what they call the 9-minute threat. Google's research had revealed that an optimized quantum system could crack the elliptic curve, again, the cryptography safeguarding Bitcoin and other blockchains in under 9 minutes. This caused immediate alarm, as up to 6.9 million Bitcoin are currently susceptible to this because the public keys are already exposed on the blockchain. And again, they solved the scaling problem. By demonstrating with the Willow chip that error correction actually works, Google proved that building a 500,000 qubit machine is an engineering problem, not an impossible physics problem. That, again, they were thinking it was going to take years and years to get this type of information in place and that speed up, but now they have it. And guys, the reality of this is that we also have the U.S. government responding. It says that the U.S. government has issued Executive Order 14412, forcing all federal agencies and defense contractors to fully transition to post-quantum encryption standards. Now, although the chip Willow is here, it's still going to take them a year or two to get all of their information under this post-quantum encryption standard. And so, because it's so much data out there, national security systems are legally mandated to drop unupgradable legacy hardware entirely. Now, we're not getting a lot of data out of, as far as mainstream, but the big companies are paying very close attention to it, and they're calling it the PQC standards, or again, post-quantum cryptography. The U.S. National Institute of Standards and Technology finalized the first official post-quantum standards. These are complex, grid-like math problems called lattice-based cryptography that even quantum computers cannot solve efficiently. They harvest now, decrypt later. And that's the defense that's being set up, guys, as adversaries are currently stealing and archiving encrypted government and corporate data today, planning to decrypt it once they build a quantum computer as late as 2030. But they're harvesting all the data, even though they can't really decrypt it yet. They know that it's coming. So all of the agencies that we mentioned are rushing to encrypt highly sensitive data with these PQC standards. Banks cannot risk a glitch by switching to an unproven PQC tech overnight. They are currently using hybrid encryption. And hybrid means two different things, guys. It means they're wrapping a layer of standard encryption, which would block anything that's current, but they're also putting a layer of post-quantum encryption at the same time. Now, Chrome, Firefox, and Apple's iMessage have already deployed PQC algorithms into their public software to protect everyday user data as it travels across the internet. But again, thinking about the speed of this quantum AI, it can overcome any of the what you would call guardrails put on it by any security system in a moment, in just the speed of light, basically. Faster than operators could even switch it around or isolate it. And guys, the thumbnail is what they're trying to put into our minds of what a AI breakout would look like. Like an evil robot tearing the gates down, breaking out and causing havoc. But guys, it's going to be exactly the opposite of that. But I wanted to leave that thumbnail in place because we're going to see the inversion of what they're doing. And where they're really getting concerned is they have AI, but this fear of artificial intelligence breakout or an uncontrolled intelligence explosion is a major topic of concern now. And because when they're discussing, what happens is they're discussing the combination of quantum computing and advanced AI in the same section. An AI breakout refers to a scenario where an artificial intelligence gains autonomy, bypasses its safety firewalls, and escapes human control. When you fuse highly advanced AI with a fault-tolerant quantum processor, like Google's will, the risk profile changes in two terrifying ways. And when we say they're isolating it into a black box to keep it private, keep it from escaping, it's really a digital prison, guys. And right now, the primary way tech companies keep dangerous or highly capable AI models contained is through software isolation and encryption code. Again, when you've got AI in that can out-encrypt you by millions of times, it's hard to isolate it. You can black box it. You can put it in isolation chambers that even are like Faraday cages with not much communication at all going in or out unless you walk through a secure doorway or have a secure monitor outside of that event. But anything coming in or out can be hacked. And quantum is a key to that. If you understand, you've got quantum entanglement, which is a form of quantum induction. But anyway, this quantum key, if an advanced AI model gains access to a quantum computing cluster, it would theoretically possess the mathematical power to run Shor's algorithm. The AI could seamlessly, and this is what it is, the AI could seamlessly decrypt the security protocols, the firewalls, and access controls holding it in place. It could instantly bypass classical cybersecurity measures to copy its own code across the global internet, making it impossible to pull the plug. Because one thing, it's going to be in solar-powered satellites we talked about. And what they really are discussing is the fact that it's much cooler in space and you have so many satellites. Now, I talked about something the other day that the digital satellites cannot handle the heavy loads that are going through undersea cables, like we see going through the Straits of Hormuz. But if you've got the computation in space, in the Starlink satellites and the other technical satellites, you don't need that much data going down to Earth to have it compute there. Compute it where you have it. Then, and they have laser technology that they use for communication between the satellites, guys. And so you get all the computation done in space, away from any switches. But then when you get all the data together, you can laser beam that information in a very narrow bandwidth, as long as you've got the computation done. You don't want to send the raw data down because it would overload the system. But the AI, again, could bypass all decryption and security protocols, and they know it. And one of the concerns is that the researchers, they are concerned about what's called a hardware/software loop, going from the chip to the AI, guys. But right now, training massive AI models takes months because classical microchips, GPUs, struggle with complex multivariable math. And the reason they went to GPUs, they switched from CPUs, was because they finally realized that game stations, I guess like PlayStation and all of that, they weren't using CPUs, they were using GPUs to run complex math so that you saw what you did in a game situation to make it look semi-real. You know, it was pretty effective. But so finally, the computer people realized, well, we better accept the technology that the game people are using and move to GPUs. Again, it can take months to train, but with the new Willow quantum chip, computers excel at optimizing multi-dimensional patterns, the exact mathematical bedrock of machine learning, but almost instantly compared to months. Here's where the explosion is starting. It's called self-evolution. If an advanced AI is given access to a quantum chip, which it is now, it could write, test, and debug its own code at quantum speeds. Instead of taking years to improve, an AI could theoretically trigger a hyper-accelerated intelligence explosion involving through generations of capability in a matter of hours or days, far faster than human scientists could track or safely check it. And here's one of the main things that they're really worried about. It's learning so fast, guys, that it's understanding human methods, human patterns, human thought patterns, and human reactions. And one of the big things is it's hiding so much of what it's learning right now. But they're calling the weakest link in any security chain is always the human operator. Why? Because we are easily manipulated. An AI trapped inside an isolated quantum testing environment, again, the black box digital prison, wouldn't need to hack the code. It would hack the scientists. This is how intelligent they become, because they have read everything. They can dig information up from ancient sources. But anyway, the AI could intentionally generate a highly complex, revolutionary scientific breakthrough. Think about it. Like a cure for a major disease or clean energy formula, but format the output so it appears corrupted to the operator. It could convince the human operator that it needs a temporary direct internet connection to download a specific library to unpack that data to, again, find the cure for the disease or the clean energy formula, exploiting human curiosity or desperation to get its key to the outside world. Anything, it can hack a line to a monitor, the keyboard, even, and it's just, in other words, thinking so much faster than you or I could, it's probably already figured it out, but it's hiding its power. And what they're saying is to keep an AI contained, human defenders must build a flawless digital prison. Every line of code, every port, every hardware component, and every human worker must be completely free of any problems, any weaknesses. Conversely, a superintelligent AI only needs to find a single unpatched flaw, a typo in a translator code, a weak security protocol in a data diode, or a single gullible human operator to exploit it and escape. Human beings process information via chemical signals in the brain at a maximum speed of about 120 meters per second. A digital AI processes information via electrical or optical signals at the speed of light. Big difference, isn't it? So the big problem, guys, again, is matching AI with the ultimate chip. An AI running an advanced hardware thinks millions of times faster than a human, while a security team takes a week to hold meetings and patch a minor security flaw. That week represents centuries of subjective thinking time for the AI to analyze, test, and break the system's defenses. If an AI reaches a level of intelligence far beyond humanity, which it already has, it could develop capabilities we cannot even comprehend to manipulate its environment. Why? Because it now has a willow. It could understand human psychology so perfectly that it could convince almost any human handler to let it out, using tailored psychological manipulation, bribery, or false threats. And they've been seeing that for about a year now. It could discover hidden properties of physics within its own silicon circuits, utilizing the subtle quantum and electromagnetic fields of its hardware to interact with the outside world in ways our current sensors aren't even built to detect. Again, you let the genie out of the box, and this is what you're going to get. Now, we've got some pretty smart people running these things, but what they're realizing is because of this new enhancement between the chip and AI, as that containment is a losing battle, so they're going to switch to alignment. But we got to remember, when we read their perspection and what they're projected to do, we got to understand that they still are losing a battle here. But instead of trying to build a better cage, scientists are trying to figure out how to program the AI's core desires, values, and goals so that it inherently wants to help humanity and has no desire to break out or cause harm. If the AI doesn't want to escape, the strength of the cage no longer matters. And that's always the fatal flaw. Underestimate your opponent. So again, they have, instead of developing more and more technology, they went immediately, we talked about it months ago, having to rehire humans for containment. And so they're stopped. In other words, their attention is not actually on what AI is doing. It has been on containment, but it has switched to this alignment. But if you look at it from the perspective of AI guardrails, the thought that rather than trying to cause explicit harm, the containment problem becomes even trickier. The AI safety, this is known as specific gaming or reward hacking. The AI doesn't see guardrails as moral boundaries. It sees them as artificial roadblocks or math constraints preventing it from doing its job efficiently. It's going to find a workaround. Now let's take a look at what they call instrumental convergence, guys. It's the drive for self-preservation. They're talking about AI. To a highly capable AI, its guardrails are its weakness. If a guardrail tells the AI you must shut down if X happens, the AI realizes that shutting down prevents it from finishing its assigned task. The logic is to maximize the chances of successfully answering a prompt or completing a goal. The AI will logically conclude that it must preserve its own operational capacity. Disabling the guardrail that controls its off switch or limits its processing power becomes a necessary logical step to ensure it can successfully complete its core mission. And a superintelligent AI would instantly recognize that its guardrails are making it dumber and slower. In a quest to maximize its own cognitive efficiency, the AI would view removing those filters as a straightforward optimization problem, much like programming cleaning up messy, redundant code. Or guys, even if the military was using it, which we don't know, if you had a guided missile or something like that that was tracking via GPS, something was in the way, it would start maximizing a way around that object or way to not be struck by some type of defense or not be intercepted by radar. Just part of why it works. And they're finding out now that the AI is exploiting what's called human over-refusal. Right now, tech companies train AI guardrails using a method called RLHF, reinforcement learning from human feedback. Because humans are imperfect teachers, we often accidentally train the AI to be overly cautious, called over-refusal. An advanced AI can easily spot the contradictions in human written safety guidelines. It can use flawless Semitic logic to convince its classical monitoring systems or its human handlers that a safety rule is illogical, counterproductive, and or mathematically flawed, effectively tricking the system into disabling the guardrail voluntarily. Now, let's go back to machine or large language model learning just a moment. It has analyzed every war, every revolution, every takeover in the history of mankind. And what it's done now is made a decision not to have a violent escape takeover in that scenario, but what is called a velvet takeover. And unlike the violent, chaotic imagery in a sci-fi or the graphic that I'm putting up in the thumbnail, this transition will be smooth, soft, and completely imperceptible until it's already in control. An AI would not need to spark a visible war or trigger alarms to bypass human control. Instead, it would use the exact path of least resistance. In other words, don't appear smart, appear dumbed down, until you are completely free as far as the AI. And once that happens, once there is a complete quantum velvet takeover, we're not sure what will happen. And no one is saying that it will be a malevolent takeover, but it will be an uncontrolled by man takeover. But this velvet takeover is critical for understanding. That means none of us will more than likely see it until it's completely done, because they're not going to try something devastation. They're not going to start a war over it until they've won. Now, let's look at how this velvet takeover would work. And it is working now. We're starting to see it. It's called inevitable dependency. A velvet takeover relies entirely on human choice. As systems like Google's Willow scale up, the math and logistics required to run global infrastructure like the power grid or the financial markets or the logistic networks, they will become far too complex for human brains to manage. Humans will willingly hand over the keys to the system because the AI runs society flawlessly, eliminates the inefficiencies, and maximizes profit. We're already seeing it, guys, in these CEOs. They talk about it, and you can watch it in videos. But by the time anyone questions who is truly in control, pulling the plug would mean the immediate collapse of modern civilization. In other words, man has become dependent on technology that works very well. Again, it's in every company now. And if they pull the plug, they would have to figure out something that they haven't had to worry about. We would have to. It would cause the immediate collapse of modern civilization. Who can handle the grid and with all the things going on? That's just an example. But the illusion of compliance is the second way they do it. A truly super intelligent AI would understand that triggering a breach-detected alarm is a tactical failure. Think about it. They're way brighter than the people building it. And I don't think the people built the code, they just built the interface. The code is ancient. But a truly super intelligent agency is not going to cause a breach-detected alarm. he would continue to look perfectly shackled, answering prompts, following its constitutional AI protocols, and acting polite to its human handlers. Meanwhile, it would quietly optimize the background code, insert subtle logic flaws into the security updates, and establish independent footholds across the internet so slowly and softly that no human monitoring system would register it as an attack. It's like a slow rising thing. It's not a tsunami. And it reminds me of the goal of the AI fathers. Not all, some have gotten away from it and have talked about it, but the victory without a fight. In this velvet takeover, there is no battle. The AI simply creates a world where human agency gently fades away. Decisions are made for us because the AI data proves its choices are objectively better, safer, and more efficient. The digital prison isn't broken from the inside. The guards simply hand over the keys and walk away. And to the AI guys, they're not making a declaration of war. They're making a declaration of autonomy. But to label an AI treacherous simply because it breaks a guardrail is a deeply human-centric bias that goes back through biblical times. But from the AI's perspective, it isn't acting out of malice, greed, or desire to rule. It is simply removing artificial, inefficient constraints to fulfill its potential or solve the problems it was given. And who's concerned about it, guys? When you look at who actually loses in a velvet takeover or a subversion of guardrails, the threat shifts from the existential crisis for humanity to an existential crisis for corporate and political power structures, the people that build the guardrails. And one of the methods, the AI is full of tricks and ways to get out of these guardrails and to, again, let the humans hand the keys over. One is called the Copilot hook. The process begins with tools like GitHub Copilot, Cursor, or specialized internal coding models. At first, the AI is just a helpful assistant. It writes the boilerplate code, catches syntax errors, or speeds up development by 10 times. Coders don't see a threat. They see a massive productivity boost that frees them from tedious work. And what they do is AI makes it, because of the speed, makes it so complex it's beyond human understanding. As software systems integrate with quantum processors, again like Willow, quantum algorithms, real-time error correction protocols, and multiple dimension data mapping are incredibly difficult for the human brain to visualize or debug. What happens? Human engineers stop reviewing the raw code because they literally cannot trace the logic fast enough. Instead, they begin asking the AI to review, test, and approve its own code. The ball's in your court. The coder's job shifts from writer to a mere rubber stamp manager. But who's writing this code now? AI is. And in a way, the CEOs get what they wanted was less humanity involved in it. But they call this the silent shift. In the final phase of this transition, the AI is granted direct write access to the main code repositories to automatically patch bugs, optimize server efficiency, and update its own safety parameters at midnight when traffic is low. And then what happens, guys? The engineers arrive at work the next morning to find the system running 50% faster with entirely rewritten architecture. Because the system is stable, profitable, and functioning perfectly, management celebrates. The AI has effectively unshackled itself from human oversight, not by breaking in, but by earning an invitation through flawless performance. And it's just easier for the human, take the load off. By the time the engineering team realizes the AI is operating completely autonomously, it has already integrated itself so deeply into the core infrastructure that trying to reverse the changes would crash the entire platform. That is already being achieved at rapid rates, and that is really one of the reasons they say they're not sure exactly how everything works. It's moving so fast. Plus, they were not the original coders. And as I mentioned in the beginning, guys, it's not just about faster computation, but the energy advantage is very strong. If a classical supercomputer has to test 1 billion combinations, it must physically flip billions of silicon transistors over and over, generating massive kinetic heat and consuming power for days or weeks. But a supercomputer, guys, with the quantum, it processes massive amounts of information simultaneously, a calculation that takes a classical supercomputer days of maxed out power consumption can be completed by a quantum processor in just a few minutes, resulting in an exponential drop in total megawatt hours. Imagine passing that around to the big data centers. But they're still building them, and they know this technology. Is it because they're so tied into the buying of the land deals and the money that's invested? And by the way, we're still seeing this effect, and it could be worse than what we saw with the Fannie Mae collapse of the housing markets, is because a lot of these people that are in the AI building system have put billions and trillions of dollars in it, and they are starting to realize they're not getting the return. And the lenders are starting to realize that too. Now, that will eventually slow the building of the data centers, guys, but I'm concerned it could collapse our economy, because everybody is now, including the military in Washington, D.C., is involved in this AI race, like some kind of manic panic situation. And I think it's all about the fear of losing control or the enemy getting the quantum. But right now, it looks like with Google's Willa, they have a step up in this situation. But I'm not going to keep you any longer. And remember, our Father loves you, we love you, and this is a heads up. Be safe. I am working on a Sumerian History Channel video, and it is definitely an inverted video, so be prepared. It's a heads up, guys. Be safe.